Going to be our last video involving trigonometry for a while. Last time we're going to talk about polar coordinates. Now, polar coordinates are a little different in that with polar coordinates what you do is you measure an angle and then you measure the distance from the origin. In polar coordinates, this origin is called the pole. And each of these concentric circles represent 1 unit. So this is 1 unit from the pole, 2 units, 3 units, 4 units, 5 units. So if I want the coordinates of A, first thing I do is find out how far it is from the pole. So that's 1, 2, 3 units. So for A, I would write this as 3 units, and then I look for the angle, 30 degrees. So this is what A is. Let's do B. Well, B is 2 units from the pole, and the angle's 180 degrees. And you do the same thing for C and D. Now, in example 1, they're asking us to label it in 2 different ways here. Now, one of the ways you can do this is just by adding 360 degrees or subtracting 360 degrees. So I could write this as -5, 315 degrees plus 360 degrees, or I could do it as -5 and then 315 degrees minus 360 degrees. And if I wanted another point, I would just either subtract or add that again. So this gives me -5, and this turns out to be 675 degrees. This one turns out to be -5, and if I subtract that, I get a -45 degrees. Now the reason these works is because these angles here are coterminal. We talked a little bit about that. Now, polar coordinates don't have to be measured in degrees. You can measure them in radians. And I've left 3 here for you to do: A, C, and E. Now the other thing we're going to do is convert between polar and rectangular. Now rectangular is just the XY coordinates there. So if you're given something in polar and you want the X value, it's going to be R, which is 4, times the cosine of 60 degrees, and the Y value will be R, 4, times the sine of 60 degrees. Now read this information here. Now the cosine of 60 degrees is 1/2, so this becomes 4 times 1/2, which is 2, and the sine of 60 degrees is the square root of 3/2. So this becomes 4 square roots of 3/2, which is just 2 square roots of 3. And that's your conversion. Now if you want to go the other way, you're going to have to find the angle. So your angle, we're going to use the tangent for that. Tan of theta. Let's do, okay, I'm going to do D down here. I'll leave A for you to do. So the tangent of theta is going to be the Y value divided by X, which is 0 over -7, which is just 0. So theta is the inverse tangent of 0. And I'll stay in degrees for this. Second inverse tangent 0 gives me the angle 0. And I want a 0, not a theta. Okay, now if I want to find this magnitude, this R here, I'm going to use the Pythagorean theorem. So R squared is -7 squared plus 0 squared, which is 49. So R equals 7. So in polar coordinates, this would be 7 and 0. degrees. Okay. Let's do one more. The tangent of theta is -3/6, which is -1/2. So theta is the inverse tangent of -1/2. And I'll use the calculator. Second tangent, -1/2. So this is approximately a -26.6 degrees. Now if I want to find r squared is equal to 6 squared plus -3 squared, which is 36 plus 9 is 45. So r is the square root of 45. And in polar coordinates, this becomes the square root of 45 and 26.6 degrees. And then you're done. Okay, now that's all we're going to do with polars. There are other things you can do with this too, but for our purposes, this is probably all we're going to need for calculus. Okay, we're going to stop the video here. This will be the last video for the trig section. Now we've got one more section to get through this week before you take your midterm exam. So catch up, take the test, get it done by Friday, and we'll start the second half of the course on Monday.